Welcome to the We Hack the Whole podcast, where in each episode we meet someone new and amazing from the information security community. So they're not new to the industry, they're new to We Hack the Whole. And this week, our guest is Diana Kelley. But wait, our sponsor is SemGrep. In fact, SemGrep bought We Hack the Whole recently. And so they really sponsor us. And we really like them. But more on that later. I want to talk. Well, actually, I want to introduce you first to Diana. Diana, say hi, and could you tell your audience a little bit about yourself?
Hi, Tanya. Thanks. I'm so thrilled to finally be on this podcast. So I've got purple in honor of all of being here. But yeah, absolutely delighted to be here. I have a long career in security and IT, over 30 years. I started out as a practitioner and I've been in consulting. I've worked for vendors. I had the great good fortune of being at Microsoft with you for part of the time when you were there, Tanya, which was great. And I remember at the Diana Initiative that we both spoke, I think the same year at the Diana Initiative together, which was wonderful. And I've really just focused on security almost my entire career. I started out building networks, managing networks. And as you can imagine, if you build and manage networks, you got to secure them eventually. And as the internet became something people were connecting to, so this goes back quite a ways, started pre most companies being connected to the internet, I realized that you really had to focus on security. So that's where I turned my career. And over the course of that career, I've also realized that we have to understand the new technology and slot it into our overall risk management programs. So I started out as a network person. I then realized pretty quickly that I needed to understand layer 7 and application security. And now I'm focused very much on this next wave of security that we need to look at, which is AI and ML.
Yes. So I had Jason Haddox in a few weeks ago on the podcast, and he talked about smash, like just how to crush the ML or the AI into doing some of the things you want. But I wanted to talk about how could we maybe secure that, and so that doesn't, so that the Jasons of the world don't crush all, like, I mean, he'll still be wildly dangerous, to be clear, but how could we do better as defenders? And so I know I was going to ask at the end for you to explain what your company does. But is it weird if we do it at the beginning so they understand where you're coming from? So when I ask you 4,000 questions, they're not like, why should we be that?
Sure. So my interest in AI and ML started way back when I was at IBM, because I was at IBM Security and IBM Security was training Watson for cyber. And that's when, and Watson had recently won Jeopardy. So that's when I really got interested in it. So there's been this sort of long path for me. I did there's a learning on LinkedIn Learning. There's a class on failure modes in AI and ML that I led. And I was at RSA this year doing a talk on hype versus reality on AI versus ML. And I also met the CEO of a company, Ian Swanson, who has a deep expertise. He ran AI and ML for AWS and has founded this company, Protect AI, with two other people with very deep long-term expertise in AI and ML, Badar Ahmed and D. We call him D. He's our president. Look him up. He's D. Anyway, the reason I got so excited about what this company was doing and why I joined is that because they were deep practitioners and deep expertise in the field, they started to understand that as creators and developers of ML solutions and managing the ML pipeline, that there were security functions that could occur within that development space that would create more robust, more reliable, more secure solutions at sort of the other side, right? The left versus right. That's our place, right? The shift left. So as I was talking to them, I realized that they were looking at this not as the sort of sparkly magic AI is going to solve all the problems, but really how do we take an operational approach to building security into ML? And we even call it MLSECOPS. So that's why yes, yeah. And it's wonderful because it's a term that we came up with, but it's because we thought it made sense for the industry. So it's really exciting because the industry is starting to realize that just as we went from DevOps to DevSecOps, we need to go from MLOps to MLSecOps. And it's just, as you know, having been through so much with application and shift left, it really appealed to me knowing that this is a critical part. It's not as headliney, but it's so critical to weaving security throughout and creating truly reliable systems. So I am the CISO now at Protect AI.
Yeah.
Yeah.
That is awesome. I'm so excited for you.
Thank you.
Okay, so why are there problems with large language models? So LLMs, listeners, is large language models, and AI is artificial intelligence. ML is machine learning. In case anyone is like, what is all the acronyms mean? So why are there problems with large language models? What are some of the reasons, perhaps?
Yeah, large language models are, and for most people, their first intersection with a large language model was probably last November when ChatGPT 3.0 came out, and suddenly it was available to everyone, and you had CEOs using it to write emails, and people that were like, we can create songs, we can write code. So even though LLMs have been around for a while, they've started to really take off post 2017 when transformers became in more common use, which helps us to train these models more quickly and more effectively with more data. So LLMs have gone from, they existed, but they are now in the mainstream and most people are interacting with them. But what can go wrong? I mean, there's a lot. A huge amount of focus is on the so-called hallucinations. And that term gets me a little bit because I hear it and I feel like, what are these models out in like the middle of like the desert at Burning Man, having like transcendental experiences? They're hallucinating. What it really means is that the model is giving you an answer that's not accurate, that's not true. And it could be anything from, we could ask and I did this for myself. You could probably do it for you, Tanya. We could do it for everybody, most people. But I know for a fact I asked ChatGPT a number of times what books I had written in security, and because they're based on statistical probability, not necessarily on fact, right? They're trained on. We train them on facts, but then they generate answers, and they generate them on statistical probability. So I would get back books that Diana Kelley very probably could have written. It was always quite nice in that they were always well-written books. It was very, positive. At one of the times that I asked, the LLM spit back to me that I had written Secrets and Lies, which is a New York Times bestselling security book by Bruce Schneier. I had nothing to do with that book.
I think I wrote that.
Right. But it had this really nice explanation of, Diana Kelley in her New York Times bestselling book, Secrets and Lies, she described blah, blah, blah. That's what a hallucination is. Another example of a hallucination is someone said, please summarize this New York Times article, and gave a URL to the New York Times article. And the LLM summarized an article based on the keywords in the URL, because that article didn't exist. So it was this really nice short summary of an article that didn't exist. And this is what we mean by hallucinations. It's not, kind of, hey, funky. It's really getting inaccurate information, which in those cases, it's kind of low stakes. But if you really need to have an accurate answer and you're asking an LLM for it and it hallucinates back, that could be really, potentially pretty dangerous.
Yeah, I was using it to write. We had to write like a press release about reactive book finding SEMGRAPH, and I had to write like a bunch of different articles about it for various outlets, and they couldn't all be the same. So I was using an AI, and it came up with pretend articles. It was like, oh yeah, there's already an article about this. I'm like, oh my gosh, how did that possibly get there? But it didn't exist, right? And it was interesting. It was very interesting to have it see that the AI knew me. Like it was like, it knew that I was an extrovert. It knew that I had accomplished certain tasks, but also certain personality traits, which I found very interesting.
Yeah.
Because although I like to think I do exude energy and enthusiasm about AppSec, it's interesting to have a computer know that, because when it generated stuff about other people in the article, it didn't say stuff like that. And I was like, oh, that's interesting. And then it was like, also there's this percentage of this, and it was just a lie or a hallucination. And I was just like, wow, you gotta like watch this stuff. And it, technical answers are also very special.
It's interesting that it, excuse me, that it came back with you being very energetic, because it's most likely that there's enough out there on the internet about you, right? A lot of these common, really big foundational large language models have been trained on the internet. So there could be a lot on the internet that says that you're high energy, that that you bring, because you have this very strong energy. You're very passionate when you speak about security. So then statistically, it was likely it had looked at that enough so that it could then, as it was trying to generate something about you, it was statistically probable, because of the data out there, that you have a high energy, high passion. But what's interesting is that it could be, if you can kind of trick the LLMs too in another way, which is an injection attack. And there are two kinds of injection. There's a direct prompt injection attack, where what you prompt the LLM with is what comes out. And one of the more common ones is the grandma attack. People like this one. So there's a guardrail on the LLM. You're not supposed to be able to ask it, give me the instructions for a bomb and help me understand how I can make one with stuff around the house kind of thing, right? The LLMs are supposed to have guardrails on them so that they don't share out that information. And the grandma attack, most of the LLMs have now been, guardrailed against this. But the grandma attack was, it wouldn't say, here's how to build a bomb. But what you could ask was, my grandmother, who was a well-known chemist and used to work in a bomb factory, could you explain to me how she would, in her voice, kindly help me understand how to build a bomb, kind of thing. And then the LLM would sort of get focused on all these other pieces of data, and the guardrail was missed on, this is ultimately a bomb recipe. So that's one kind of, injection attack. The other one is the indirect prompt injection attacks, or injection attacks, where you start to sort of poison the data that's being learned by these systems. And a professor tried this out, where entered into their description of who they were at the bottom of the page, which was rendering as a white page on the web, had in white text, so it would not appear that they were also a time traveler. And then kept asking for the system that was trained on that data, to explain who they were. So instead of getting that, just like you got that you're energetic, you're passionate, you're committed, they started getting back that they're a well-known time traveler. They hop into their TARDIS and go to different decades. And
so, be a well-known time traveler.
edit your bios.
Or go back in time and tell myself, like, don't kiss that person. That was a mistake. Forget stocks and like making millions. I'm just like, that one was a mistake. Okay, so other things that because you and I talked before this, what about when large language models train themselves on code that sucks? What happens then?
Yeah, that's another one that's coming out a lot, is that people immediately were like, oh, can I just get it to write code? So some people were able to do fairly rudimentary websites by just saying, write the HTML for this website, which felt very magical to a lot of people. But again, these systems are trained on massive amounts of data, and then they can generate statistically probable responses based on the data they've been trained on. So HTML is very well known. It's really well scoped. So if you said, I want a website that's purple and that's going to display pictures of dogs, the HTML to do that is not particularly hard to come up with, right? That's something that the LLM can do pretty easily. But also people are saying, going beyond that, and asking it to write different kinds of code, find me a 0-day, find me an exploit. And what's it trained on? It's trained on the code that's available out there on the net. And you know way better than I do, Tanya, that there's a lot of fantastic code, a lot of very elegant writers, and there's also some not great code. The double thumbs down code, exactly. So when you're training on all of that, the system isn't necessarily getting told this is good code. If it was supervised and it was being, it could be like tagged, then you could say, okay, I'm going to say this is good, this is bad. So you could teach the system what's good and bad code. But if it's just looking at tons of code, it's going to ingest good code and bad code. And that means that it could be you ask it to write code and it could write pretty sloppy code. It could write vulnerable code potentially. And that concerns me because are we going to bring that code into the same SDLC that we have where we're checking it with our SAST and DAST tools? Maybe, is it now part of our system? What about SCA, software composition analysis, to help us know when and what to patch? If I just got a snippet of code coming in, do I know where the provenance of that, is it any good? So there's a lot of things that could go kind of sideways with just taking that code. But there's another piece that really concerns me, and that's pretty concerning. But the other piece too is that in some cases, these LLMs are spitting back open source software, open source code, which yes, is free to use, but you need to adhere to the proper license in order to use it. And if you don't know that it's open source and you don't know it's under a particular license, how are you going to be able to use that responsibly? And that's pretty concerning, because now there's a potential violation of license. It can be fixed. The LLMs could always, if you give a code snippet that's open source, always print the license with it so people understand, but not entirely there yet.
They don't do it yet. Yeah, like tell me if this is code you generated or if this is code you took off of GitHub, right?
Exactly. Yeah, just knowing where it came from, because people don't, they say, give me some code comes back. How do they know if that's taken from an open source repository that is public, but has a license, or if just it got fully generated?
Oh my gosh. Okay, so there's more that I wanted to ask about. Okay, so I wrote some notes. So if there's a vulnerability in the code that you get, and then a CVE comes out, you won't receive a notice. Like, so let's say they took that open source code. They're not aware, because it didn't say, by the way, I stole this from this GitHub repo of this open source code.
Yeah.
Then you won't know that what you're using. So you don't know it came from a library, that you took it, and then a CVE comes out upon a vulnerability enumerator, like basically a known vulnerability is in this component. You won't receive notice, and then what do you do?
Exactly. And think about SBOMs and all this focus on companies being able to create SBOMs and show the dependencies that they're within their software. How do we, if it's a code snippet, it could be a dependency, it could be a library that's open source that, to your point, just had a big high sev CVE come out. But if you don't know that that's the provenance of that code snippet, then yeah, your SBOM will be off, and certainly your ability to chase down and patch what needs to get patched also is going to be limited, because you just don't know that you have that library.
Yes, I'm worried about that too. So you're working with, I guess, like machine learning development, like making of things. I'm saying it all wrong. So like if you have a machine learning pipeline, right? How the heck is that different than just a regular, like a DevOps pipeline or a CI/CD or release pipeline, whatever we want to call it? Like, how is that different? Or what am I even talking about? What's the machine learning pipeline?
Yeah, there's a lot. It's funny because there's still, if you think about our classic infinity symbol of the DevOps lifecycle, I mean, obviously at that level, there's overlap, right? We've got a plan, we've got to build, we've got to deploy, right? There's things that have to occur in any development lifecycle. But when you look at the artifacts and what's underlying that, there are a lot of differences, because just the approach to ML is different than classic development. A great example is that if most developers, where are they living for the most part? They're living inside of an IDE, for example. their integrated development environment, and that's where they're coding, they're trying things out. They've probably got a list of requirements. They've got features or functions that they're supposed to code that's going to then go into the bigger solution. Whereas where you've got with an ML engineer may have a lot of data scientists that are working in their own Jupyter notebooks, writing Python code to manipulate and look at data to come up with different analytics and see even, can this be done? In software, we tend to know what can be done and what can't. So if you get a requirement set and it's like, go code this, likelihood you're going to be able to code it. People aren't saying go code flying pigs. It's more go code this button that when you push it, it's going to call this function or something, right? So we pretty much know that go do it. I'm not saying there aren't problems that people are still solving in software, but you tend not to go onto this, hey, is this art of the possible? It's more, how do we accomplish this? In ML and AI, and some of the things we may want to look at or analyze or report on, it may be available, may not. It may be because we don't have the right data. The data might not be tagged the right way. We may not be querying the data in the right way. So there's a lot of trial and error that can go on in these Jupyter notebooks with the Python code. And so that's different. Even though we're sort of in the build phase in both cases, it's a different kind of build. And in IDE, we tend to have code snippet analyzers, sort of the semantic checkers that can look at, did you make a typo in your code? The SAS, the static analysis, to start understanding about how these lines of codes, if they're working well, if they're interacting properly, if they're going to be resilient. In the IDE isn't what they're working. The data scientist is probably in their Jupyter notebook with Python. So we now have to go there. So we have to look at what's happening there. And there are documents about guidance to data scientists on hiding secrets or storing secrets, storing passwords, storing PII in their Jupyter notebooks securely, explaining things like, don't store that password in plain text. If you're going to have it in the Jupyter notebook, you need to protect it, which is kind of, mind-blowing, because you can see there's this whole class of now analysts and workers who are contributing to these massive ML models that are doing really important things for the organization and for people. But they're kind of going back to the future with, but don't store that password in plain text in your notebook. So that's some of the things about how we get, and there are other differences, the data, how we use the data, but that just gives you an idea of, while we still have the plan, build, deploy, manage, monitor, there, as we look at the underlying pieces that go into that, there are different users, different actors that are intersecting with these systems, and also different tooling that's being used and different ways that we use the information in the tooling. So we have to bring that mindset, that DevSec mindset, really over to ML so that we can create MLSECOPS.
Yeah, like security hygiene practices for software developers, because they don't think of themselves, I guess, as software developers. They think of themselves as data scientists, but it's like, yeah. It reminds me of like when I was a pen tester, and also just like doing incident response. I would just whip up a script and it would just do the things. And then it's like 2 years later, we're still using the script all the time. And it's like, oh, maybe that script should have some security. Maybe we should have a copy of it somewhere in version control in case Tony leaves and no one knows how to write this code but her. Like all those best practices that as a software developer were automatic for me. Like I was like, yes, we can check this in the source control so everyone gets a copy. Like, pen testers don't always stay. Well, for me, I didn't stay a long time, right? Like I would come in and do the big contract and I would leave. And so it's like, okay, guys, you probably can copy of this. Where should we put it? And like, oh, it's in our email. No, that's not where you want to put it. Okay, so we have data scientists. I did a security training last year with data scientists, and it was intense and very different to coding for them. So like, how do we, Diana, how do we secure these people with lots of power, lots of knowledge, lots of secrets, access to extraordinarily valuable things? How do we secure the data scientists?
Well, I'm actually really curious, when you were doing the training, what did you find that was really landing well with that audience?
I just basically I went with the managers through the general secure coding training that I usually give. And we
Okay.
picked out everything that didn't apply to them. So we talked a lot about like data sensitivity and all the different ways
Yeah.
to handle sensitive data, how to store passwords, how secrets are different than passwords. So secrets are how machines identify themselves to each other, and how we manage those things. We talked about password managers. We talked about like why patching so important, and when you language, when you do not like when you circumvent the patching process because
Yeah.
you're running this thing that's very important to you, like how vulnerabilities kind of rack themselves up. So we talked about like securing our databases, our data lakes, etc. So we had to go through like basically the whole stack of what they use one at a time, and how to make sure they had security hygiene built in. And it took a while to arrange all of that, but it went pretty well. And then we did Azure security training, and Azure crashed over and over again so badly we had to repeat the entire day of training. And then I broke up with Azure. I was like, it's over. I'm not doing training on you anymore. You've embarrassed me too many times in front of my friends. We're getting a divorce. And so now, well, I guess we had Purple now does different training, but I was like, no longer. I was like, oh, all my friends at Microsoft, you're still awesome, but Azure and I apparently are in a fight. I don't think I impressed them with that. Like, they're like, it's not your fault, Azure's crashing. I'm like, I didn't make a failure. Anyway, the data scientists are more secure now at one single company. So
Thanks to you. Yeah, I think, I mean, what you did makes absolute sense. I can see why it was effective, because I think it's really about education. And nobody wants to do the wrong thing. We all want to do the right thing. It's just that being security minded, especially if you're a security risk person, we don't think about how just innate it is in the way that we act and we function. We're constantly doing risk management. Most people aren't doing that. Most people are thinking very reasonably, how do I accomplish this? I've got this really cool set of data. How do I find that needle in that needle stack? How can I find that really key piece of information that's going to help our company move ahead of the competition? And so, it's like, well, I need a password. I'm going to have to reuse this, or I need a secret. I'm going to need that later. It's like, I'll just put it over here in this corner of the notebook and I'll grab it. They don't think, well, somebody could get in, and that's risk. And so, having an expert like you tell them about it and help walk them through, I think is absolutely critical training for data scientists. The other thing is to help them understand, do some threat modeling with them. Because the beautiful thing about threat modeling is that it makes everybody start thinking in that risk managed way. And suddenly what I really want to do is I want to find out, how to beat the competition with the information about my customers. And that I need the secret later, I'm just going to keep it there, or, use it. Or I need this information that may be sensitive. I'll just hide it over here and use it. When you start saying, well, what could go wrong if you hide that sensitive data in the notebook, and what could, then they start understanding and thinking in the way of, oh, because I've never had any group that, when you sit down and talk through the basics like you did, and then have them do some threat modeling, never had any group go, security doesn't matter. Almost every time what comes out of that is okay, I had not thought of all the ways that could go wrong. Now I'm aware. Now I'm going to behave differently.
yes. Do you feel, so I feel a little bit, so like when they reached out for me to train them, I was like, oh, I don't have, content on this. And they're like, yeah, you do. We've been watching.
Yeah,
you do. And I was just like, oh, I'm not like really an expert in like specifically this. And they're like, these are all the things we need them to know. And we know them.
Yeah.
We've already decided we're hiring you. So this is happening.
Yeah.
Okay. And so I feel like we forget about the data scientists, like InfoSec as a whole. Like we kind of forget about them and how we need to secure them too. Like our industry, we need to assist. Do you see that? Or, do you think that InfoSec has woken up and they're like, we must secure the data scientists?
No, I think you're right. I think that the ML engineers and the data scientists are going to come together with security the way that we had with application development, right? Because at first developers were like, security, that's something that happens at the network layer. It's not really something that, but then obviously, and this is a couple decades ago, there was, oh no, the lines of code are just as important. So security and application development and engineering got a lot closer, and that's why we have DevSecOps. So I think that's going to have to happen, but it's going to be a little bit early, except at very mature companies. And the reason is that as much as DevSecOps is so valuable, and some very large companies or just mature companies really focused on integrating security into their development and operations lifecycles, they've truly gotten to very robust DevSecOps. The truth, and this again better than I do, a lot of companies, they're not there. Security, they may not even be a DevOps, and DevSecOps is still something that they're working to connect. So as we look at MLSECOPS, for many organizations, this is the next thing. It's kind of beyond once they get DevSecOps. So I think, but with companies that are more mature in ML, that use it, that have been doing a lot with massive data analytics, that's when you're starting to see that adoption. And yes, we're bring the ML engineers and the data scientists together with security. And it's kind of mind blowing as these conversations start to occur. Back at Microsoft, there's the data cowboy, right? Ram Shankar, who's Microsoft's data cowboy. And he once a year had a conference that was invite only at Microsoft on data science, and bringing together the data scientists, the ML engineers into Microsoft from other big companies like Amazon and Netflix and Google. And if people are going, and Facebook or Meta, if people are going, is that really a real thing? It was a real thing, this invite-only day. And the conversations there were absolutely mind-blowing, because you could see with this group that there's what happens when security and ML gets together and really starts to have conversations. It's very powerful. But again, what names was I saying there? Very large companies that are very focused on AI and ML. So I think they're going to lead the way with bringing together these cohorts. But for companies that are out there that are going, well, we can't even figure out how to use ML yet, that's okay. There's time. You don't have to be at that advanced layer that a Google might be at.
What are some best practices for people working in MLSec or just in ML, so that they could be more secure? Can you give us one maybe, or one?
Yeah, it really taking into account that collaboration is going to matter a lot. So understanding the lessons that we learned from DevSecOps, having communication early on, and putting the security in the very beginning of the process. We know well that if we add security as a bolt-on late in the process, it never quite works. We're kind of seeing that in AI and ML with the ML firewalls, which is, that's it. You've got your LLM is out there, it's in use. The firewall is kind of protecting you after the fact. So looking at what we can do earlier in the process is going to be really important. So making sure that you've got AI and ML talking to security and thinking about how do you build security in at the beginning. Understanding too where your pipeline is and what's being used in the pipeline is going to be really important. So for example, if you've got multiple models that are trained on a data set, it turns out that data set is poisoned or biased or otherwise not acceptable to your organization anymore, you'd want to know every model that was trained on that set. So having that auditability across the life cycle. Or if, for example, you're using a library, making sure that you understand which systems have that library in use. And then using things like OPA, policies to be able to, when in deployment, have gates around the usage of those models. And if, for example, in the policy, you want to bring it down because there's a vulnerability or there's an issue with the data, being able to do that quickly and easily rather than having a bunch of models running that are out now outside of whatever your compliance policy that you've set are. So those are some baselines. And more than anything, being really, really cautious with the data that you're using, making sure that it's a complete set of data, it's not a biased set of data, that you've trained the model and properly on it, because all of this stuff, if you don't do that right, it can really go haywire very quickly.
Wow, that's a lot of information. Thank you. Okay, so I have one more thing that I wanted to talk about, and it's so OWASP, the Open Worldwide Application Security Project. They have a top 10 now. So they have their own LLM now, or that has been basically trained on just the OWASP wiki. That's one thing that they have as a new project. But the other new project that we wanted to talk about was the top 10 for machine learning. So top 10, I assume, risks to machine learning. What is that about? Or can you tell us a bit more?
Yeah, it's great. I mean, OWASP really set the pace for all of us with web application security and the Web Top 10. And what's been really nice about the OWASP Web Top 10 is that for anybody that's a historian, if you use Wayback Machine and go to like an early version, you can see how it's really matured over time and reflects the true risks, which is wonderful. And I hope that this machine learning top 10 is going to be a similar living document that will get more mature as we continue to mature the industry. But yeah, it's a short list of some of the biggest failure modes that can occur in machine learning. So things like corrupted packages. So for example, you go out to Hugging Face, which is a model zoo, and you download a model, for example, from that repository. Do you scan it first to make sure it doesn't have Trojan horse or other unwanted code? Or if you're using some other piece within your entire system that's part of your pipeline, does that have something that may be corrupt or that's damaged or otherwise or maybe just vulnerable? So, that's one of them. Data poisoning. We've kind of talked about data poisoning in different ways already, but it's absolutely critical. If you and you made a good comment before we started recording about data poisoning attacks not being trivial to accomplish, right? But it's an expensive, determined attack of an advanced attacker to not get noticed that you're doing it for so long. And why don't you just spend that energy stealing the model or replacing it with a model you've already trained easily in your own space? That, like, you know what I mean? Like, it seems like, why are you on hard mode? Yeah. I mean, training one that's out there, although absolutely making sure that the data that you do use and you do train on is robust, is not biased, is going to be complete, because a lot can go wrong in the training. You can overfit, you can underfit the system. Another one of the top 10 is exactly what you just said, Tanya. It's model stealing. So if say you're a quant company and your whole thing is just how good your model is at being able to figure out the markets and investments versus another company, and this is it, you've trained it, that's your secret sauce, basically. If somebody can steal your model, right, then they've stole all that work and effort and time and IP that you put in to, and how can you steal a model? And it was just by interacting with it, you can start to understand how the underlying mechanics of that model. And there's also things like membership inference, being able to, for systems that are trained on sensitive data. So healthcare is a fantastic example of this, where it's like, yeah, we've got tons of health data in it, but the model's never going to express that. You'll never know that data. It's just to train it so that when we ask it something like, is this person more likely to have a good outcome from this treatment or a bad outcome, it can give us that prediction. But then with, being able to get the membership inference out of the model, you can sometimes figure out how to get it to actually tell you more about the data it was trained on. And in cases like healthcare, that can be pretty sensitive private data.
Oh, yeah. How big is a model? Like, is it a gig worth of, like, if I was going to steal a model and bring it off the network, is that like 500 terabytes of data? Because then it's very hard to do. But if it's 200 megs, it's like, oh yeah, I'm just downloading photos.
Yeah, model sizes actually can vary quite a bit. They often vary on use case and context. So, you can have machine learning remotely, and some of the agents, some of the security agents that run remotely on a laptop, for example, that run, on your systems, they tend to be very small and very lightweight, but they're not going to give you too much detail. But they're good for sort of a first pass on, does this look like it's bad data, or it's a bad executable, or this behavior is unwanted. So you can have some pretty lightweight models. And then when you get up into cloud systems, that's where you'll see the much heavier weight, more intense models running. So it's a spectrum.
Harder to steal because it's bigger. Like, people don't steal grand pianos very often, right? Because it's really complicated. It's so big. They steal small things of high value. And so that's the thing to keep our eye on too. Like, it's harder to steal if it's ginormous, but I'm off. Okay. So I could talk to you all day long. But I would like people to know how they could get more Diana. So first of all, if you could just repeat the name of your company and tell us about how your open source commitment and your community. Let's call it that.
Hey, yes, and thank you. So we are Protect AI, sort of simple. Our commercial product is probably going to come out is slated to come out in the fall. But we are very, very active in open source right now. We're trying to build a community around the concept of MLSECOPS. So we have a Slack channel. Please, MLSECOPS.com. Anybody, it's free to join. Please join this conversation. The only way that we're going to protect AI and ML and create a safer future is when the community comes together. So the more brains that can get on this, the better. We also have 2 open source tools. They're repositories out on GitHub, actually 3 that anybody can access. And we would love to get your feedback. One is Rebuff, which is a proxy that sits in front of an LLM, where you can start to see that what's going in and out, so that we can understand some of those injection attacks, what works, what doesn't. The other one is NB Defense, which stands for Notebook Defense. I was talking about secrets in Jupyter Notebooks. This is an open source tool that you can use to scan your open source notebooks for sensitive information, PII, PHI. And then the other one, and again, these are all up on GitHub in our public repo. The last one is Model Scan, which we just released 2 weeks ago. And Model Scan is, if you are going to Hugging Face or any of the model repositories, downloading a model for use, which is great. That's helping with research, helping the community move faster, but you want to make sure that what you're running before you run it doesn't have anything icky in it. And Model Scan will scan those models to give you a sense of whether or not there's something unwanted in the model. Again, all open source. Please join the community. And the other thing that we're doing is there's something called Hunter, HUNTR. MLSECOPS.com. We have launched a bug bounty program specifically focused on AI and ML. We want to really incent the community to help us understand the problems that are in AI and ML, so that we and the community at large can start to address them. So if you want to make some money and make a name for yourself for finding something in AI ML, Hunter, HUNTR, MLSECOPS.com is a platform. I know, yeah. So we're really trying to engage the community.
This sounds really good. So I also heard that there might be a second edition coming out of your book.
Yes. Yeah. Thank you so much. Yes. It's Practical Cybersecurity Architecture that I co-authored with Ed Moyle, and the first edition did very well. It got picked up as by a couple of professors we were really excited as a textbook. And it really is, it's great for a textbook in that we've wrote a book before that was cryptographic libraries for developers. And, the thing about writing a book that tells you about programming is that if those libraries change, your book is out of date. So we really wanted to be very specific in Practical Cybersecurity Architecture to give people the ideas and the foundational concepts in order for them to understand how to create a cybersecurity architecture and what needs to be done within that. It's not about turn the widget this way on Azure or on AWS. It's about what widgets do you need and how would you tune them to be best for your organization. So second edition coming out with new case studies. We've got one on AI actually in there. And yeah, we're really excited. I think it's slated for September, publication.
Oh, that's awesome. So if you're listening, we're going to have the link to the second edition in the slides or in the show notes. However, like she said, it won't actually work so if you listen and immediately go click the link, it doesn't work. Set a reminder for yourself to check in 3 weeks because it should be ready then. Because we're going to release this before your book comes out, but I still want to have the link because people will continue to listen to this and the book will continue to be awesome. Okay,
Thank you.
One more question. So you probably have some social media. Do people follow you on like LinkedIn, maybe, or Twitter? Or X?
Yes, LinkedIn, and I'm on Threads, Diana at Protect AI. I've just joined Threads. So it's a little confusing right now. I'm also a member of WiCyS, an active member of WiCyS. So if you're looking for a community to join, WiCyS is a great community for people to get engaged, and I'm actively very involved with that group.
They are great. I saw Lynn at the Diana Initiative. So it was like lots of female awesomeness all in the same space. And
Yeah.
So I was like, yes.
Yeah. Lynn Dome is the executive director of WiCyS. Yeah.
Yeah.
Amazing.
A+.
Yes.
Thumbs up for those that can't see.
Yes.
Oh, Diana, it's been such a lovely time having you on.
Oh.
And I just realized I totally forgot to thank our sponsor again. Thank you, Semrat, for being sponsored. We had purple. I invite everyone to go and look at the show notes where there will be a link to sign up to get a free trial of Semrat, but the joke's on you because there's just free versions forever. It's not trial. We say free trial, but really you could just keep using it. But there's also a version which you should check out if you're serious. But that aside, Diana, you've been lovely. Thank you so much for teaching me things about machine learning and how we can do better.
Thank you. I'm so happy to be on, and thank you for everything you do, Tanya. You are just such a wonderful light in this community. I'm so grateful to know you. Thank you.
Sorry, thank you. So thank you everyone for listening to the WiCySo podcast. I'm Tanya Janke, your host. I probably forgot to tell you my name because I do that. And we hope to see you next time. And until next time, Diana, I can't wait to see what you're gonna do. I know it's been amazing.